Welcome back to the channel, everyone. Today's lesson is on how to write equations for the thermal decomposition of alkanes, also known as cracking. This topic comes up in both GCSE chemistry and A-level advanced placement chemistry, so it's kind of one of those topics you need to know. So I'm going to go through what cracking is first of all with some equations, and then we're going to look at some typical worked examples from some past papers. So with that said, let's take a look. So what is cracking? It's where you take a longer chain alkane and turn it into a smaller alkane and alkene. So there will be mixed smaller alkene and alkane products depending on the conditions that are used. And there's two types of cracking. We have number one, thermal cracking, and number two, we have catalytic cracking. So with thermal cracking, it uses a higher temperature to decompose the hydrocarbon, usually around 950 to 1000 degrees C, and then again alkane and alkene products are produced. Whereas with catalytic cracking, tends to use a lower temperature of around 500 to 600 degrees C, and obviously a catalyst. So the catalyst that's used in industry is a zeolite catalyst, which is based on aluminium oxide. So the three examples here involve hexane being broken down into, different alkane and alkene products. And like I said, depending on the conditions used, you can manipulate the products that are formed. In the first example, you can see we produce just hexene as the alkene and hydrogen. In the second one, you're making C4H8, which is butene plus ethane, and so on. So depending on the conditions, you can change the products. In industry, you wouldn't actually crack hexane because it's too small of an alkane and is a very useful hydrocarbon anyway. So hexane is a solvent. It just wouldn't be used. So when I say long chain alkane, what does that mean? Usually around about sort of 20 carbons onwards. For example, like C40H82 would then be cracked into smaller alkanes and alkenes, which are more commercially useful. In other words, they can be sold for more money because they're more useful. Whereas longer chain alkanes like this, they tend to be more thick, more viscous, not as flammable, and just not as useful. So that is why cracking takes place. So in a descriptive question, which are very common in addition to the equation ones we're going to go through in a moment, please, these are the things you need to talk about. How commercially useful are the products compared to the reactant, justification for undertaking this reaction, and what can you do with the products? Well, if it's smaller alkanes, you can use them as fuels, you can combust them. If it's alkenes, it's always usually for the same thing. It's to make polymers, plastic. Okay, so lots to talk about there in a descriptive, wordy type question. What about the equation questions? Well, I have two to go through today. So it says, write an equation for one possible cracking reaction of the alkane C16H34 when the products include ethene and propene in the ratio 2:1 and one other compound. With these questions, you must remember that the products, the alkane and alkene products, must add back to give the original number of carbons and hydrogens in the starting molecule, which you can see is 16 carbons and 34 hydrogens. So let's follow the instructions we're given. So we're told we make ethene, so ethene is an alkene. We also make propene, C3H6, and we're producing them in a molar ratio of 2:1. And then finally, we've got to work out the question mark. So what could that question mark be? Well, all I have to do is subtract the number of carbons that have been used already from the starting carbons and see what I have left. So 2 times 2 is 4, plus 3 is 7, 16 take away 7, leaves us with 9. And then hydrogens, 34 take away 8 plus 6 is 14. So 34 subtract 14 gives us 20. So I can see my product is an alkane and it's 9, so it's nonane. How do I know it's an alkane? So again, quick recap. General formula, so alkenes, they have the general formula CnH2n, where n is the number of carbons. And then alkanes are CnH2n plus 2, which is that one. Write a balanced equation for the cracking of octane into propene and one other product. So octane, octagon, is a 8-carbon alkane, so C8H18. And we can see we're making propene again, plus whatever's left. Well, 8 take away 3 is 5, and then 18 take away 6 is 12. And I can immediately see that is a alkane, which is 5 carbons, so that's pentane, and this one is propene. So cracking is where you take a long chain alkane, you break it down into smaller alkenes and alkanes, which are more commercially useful. The alkanes tend to be used for fuels. The alkenes are often turned into plastics. That's it for today's lesson. If you found any value in this, please do like and subscribe and check out all of the other videos I have on my channel. If you have any questions, please do comment down below and I will endeavour to get back to you. Otherwise, I will see you in the next one.